Hence, let us plot the input and output characteristics of a common emitter configuration. So we know very well we are giving a low amplitude or weak signal as an input to the transistor, and because of the transistor action or amplifying action we will get a large magnitude signal in the output side. So base emitter, we are giving input applied, the input is applied across base and emitter, the output is taken across collector and emitter. So base and emitter terminal is known as input side and collector and emitter terminal is known as output side. So let us plot the VI characteristics. First one is an input characteristics. So why should we plot these characteristics, input and output characteristics? We will see it later. So first one is an input characteristics. In the input characteristics, you have to vary the VBE and measure the IBE. So go to the circuit. By varying this voltage, measure the VBE and IB for different voltages and tabulate the relationship between VB and IB and plot the graph. If we plot at the time, the voltage across collector and emitter should be constant. Your VCE should be constant. How will you make it constant? Just vary this VCE and make it 5 volt, and after that just vary the voltage and measure the IB and VBE. So we will get the graph like this. Red color shows that when VCE equal to 5 volt, this is the relationship between VBE, input voltage, and input base current. Suppose if I increase the VCE to 10 volt, this will be the characteristics, VCE 10 volt. So this characteristics is almost similar to diode forward bias characteristics, because the cut-in voltage is approximately 0.6 here. And next one is an output characteristics. In the output characteristics, IC and VCE, you have to plot the graph between IC and VCE by keeping IB constant. So how will you keep IB constant? By varying VBB you can control IB, so make it constant, and after that just increase the VCC, you will get different value VCE and IC and plot. So VCE in x-axis and IC in y-axis, it is in the order of milliampere. When IB equal to 0 milliampere, this will be the curve. When IB equal to 10 microampere, the collector current is slightly increased. 20 microampere, 30 micro, 40 micro, 50 micro, it will go so on. So here, this region is known as breakdown region, this parabolic graph. You should not operate the transistor in the breakdown region. So because a large amount of heat will, because the current is rapidly increasing, so large amount of heat will be produced, it may damage your transistor. So you should not operate beyond this blue line. So this region is known as breakdown region. When IB equal to 0 microampere, so below the base current, the transistor current is in 0, your collector current is almost 0. It means this region is known as cutoff region. So here your transistor acts as an off switch. This region is known as saturation region, and in between this region is known as active region. So in cutoff region your transistor acts as an on switch. In saturation region it acts as an on switch. In active region your transistor acts as an amplifier. We know the purpose of amplifier. The purpose of transistor. The transistor can act as a switch as well as amplifier. In active region your transistor acts as an amplifier. In cutoff region and saturation region it acts as a switch. So that is the purpose of transistor. In breakdown region you should not operate your transistor. It may, otherwise what will happen, your transistor will be damaged. So even though the base current is 0, there will be a small amount of collector current. This current is known as leakage current, collector to emitter leakage current. So this is how you need to plot the characteristics. So from the characteristics we should determine the operating point of the transistor or Q point of your transistor. Q point is known as operating point of your transistor, so that you can get the better amplification. So that is not, we are not going to discuss in our lecture. So the purpose of lecture is to plot the input and output characteristics of a transistor. So the collector emitter voltage you should not cross this level, and also the collector current, it has a predefined collector current, you should not go beyond this. Thank you.